is they give us a point, -1, -4. In many of these questions, we're going to use a strategy that I call draw a triangle. It's kind of a self-explanatory strategy. So we've got a point -1, -4. Well, if you go to your coordinates here and you go -1 and down to -4, that point would be right there. And they're telling us that that point is on the terminal arm of an angle in standard position. So here would be the angle starting in standard position, going all the way over to there. That would be the angle theta. So right now we know that that angle ends in quadrant 3. And since we have the point -1, -4, we can draw a triangle with that point. That makes a right angle triangle. We know that this length is 1 on that triangle, and we know that it goes down 4. And it makes a right angle triangle. That's a bad right angle triangle. That's really kind of bent. Yeah, if you kind of blur your eyes a little bit, cross them just a bit, it works out just perfectly. Now, since you know that one side is 1, the other side is 4, you could find the hypotenuse by a squared plus b squared equals c squared. We're going to do a squared plus b squared equals c squared so much that by now what I'd like you to do is see if you could just do it in your head and just get the answer. This will be square root of 17. Right? Because 4 squared is 16 plus 1 squared makes 17, and then you'd square root it. So you're going to be able to do that quickly. A squared plus b squared equals c squared, and we get the hypotenuse is the square root of 17. Now to write out all 6 trig ratios, we've got sine theta, cos theta, tan theta, cosecant theta, secant theta, and cotangent theta. And I've written the reciprocal right beside its primary trig function. All we have to do is know what is what. We also, a key thing, when we draw the triangle, this angle right here is called what? No, this one right in here. This one's the right angle, but this one right in here, the reference angle. Okay? Now, we learned yesterday that reference angles were important because if we know the reference angle, then we know the angle no matter what quadrant it's in. The only thing that changes is whether something is positive or negative, and the cast rule helps us remember that. So if we're dealing with quadrant 3 and we're doing sine, well, sine is the opposite over the hypotenuse. So we think of our reference angle, and because our reference angle is here, the 4 would be the opposite side. So for sine, sine being opposite over hypotenuse, you would have 4 over the square root of 17. And because it's in quadrant 3, and we know from the cast rule that only tangent is positive in quadrant 3, we would make this fraction negative. Now in grade 11, you learned that if you had a square root on the bottom, you had to rationalize the denominator. For the grade 12 course, they assume you know how to do that, and so you are not required to do that. You can leave square roots on the bottom. Okay? You also, in grade 12, don't have to simplify fractions. So if you got 6 out of 12 as a final answer, you wouldn't have to reduce that to 1 over 2, because they assume that you already know how to do that. Okay? Sometimes they check that assumption in multiple choice questions. So in a multiple choice question, maybe this one was written as -4 root 17 over 17 to see if you remembered how to rationalize the denominator. Right? Quick review of rationalizing the denominator. You would multiply both by root 17. And then your denominator is no longer a square root. So that is considered more simplified. But you don't have to. You could leave it as -4 over root 17. Cos is adjacent over hypotenuse. Well, the adjacent side is 1, hypotenuse is 17, and since it's in quadrant 3, cos would be negative. Tan is opposite over adjacent, so you get 4 over 1, which you could write as 4 over 1 or just write it as 4. Then for each of the reciprocal ones, you just have to flip the fraction. And if it's negative to begin with, it'll be negative as well as the reciprocal. Secant would be negative root 17 over 1, but you can just leave it as negative root 17. And cotangent will be 1 over 4. So the questions you can do for this one, or the question, is number 8.